Okay, let's start. So today we'll talk about the circulatory system, blood vessels. First we'll see the arterial system in your body, then we'll talk about the venous system. You know that arteries, veins and capillaries, those are the blood vessels, right? Okay. So, before you know about the arteries and veins, let's start this. Oh, it did. Okay. So, one thing is important to know that large arteries give blood to the smaller arteries, like this. Okay? So this is the large artery. So blood from larger artery enters into the smaller arteries. Make sense? So these are the branches of this artery. In case of venous system, it is opposite. So large vein receives blood from the smaller veins. That means these smaller veins give blood to the larger vein. And these are called tributaries. These are branches. These are branches, and in case of venous system, these are called tributaries. Okay? So, tributaries give blood to the larger vein. Arteries take the blood away from the heart. Okay? So, blood goes away from the heart to the arteries. Veins bring the blood towards the heart. Okay? And as the blood goes away from the heart, the pressure of blood, you tell me, increases or decreases? As the blood is going further away from the heart, blood pressure decreases. Make sense? Yeah. Okay. So, what happens? This is the heart. Okay. So, the artery, large artery aorta takes the blood out from the heart, and the branches of the aorta, give blood to different organs of the body, right? Okay. Then, from the end of the arteries, capillaries start. So these are the capillaries. They form network. That is called capillary bed. Network of capillary. So this is large artery close to the heart, right? Takes the blood out from the heart. Then large arteries give blood to the medium sized artery. Okay. Then medium-sized arteries give blood to the smaller arteries. Like from here, blood will enter into the smaller arteries. So these are smaller arteries. Smaller arteries. And from the end of the smaller arteries, capillaries start. So these are the capillaries, okay? And they form what? Network. And these are called capillary beds, okay? Then, what happens in the capillary bed, this is very important. Inside the capillary beds, in the capillary beds, exchange of oxygen and nutrients take place. So, exchange of chemicals. In one word, you can say exchange of chemicals take place in the capillary beds. Then the blood enters into the veins. So from the other end of the capillary bed, the venous system starts. So smaller vein, these are smaller veins, give blood to the larger vein. This is a larger vein. Okay, blood will enter into larger vein. So these are small veins, then larger vein, and then the largest veins are vena cava, give blood to the right side of the heart. So deoxygenated blood returns to the heart. Oxygenated blood gets out from the heart through the aorta. Deoxygenated blood returns into the heart via the vena cava, largest veins. Make sense? So that's the inter-circulatory system, circulation. Is it clear? Okay. So, in systemic circulation, this is the systemic circulation between the heart and the whole body. Arteries take the oxygenated blood out from the heart and gives to the organs in the body and takes the carbon dioxide from the tissue or organs and becomes deoxygenated blood. Exchange occurs here. Now you tell me, in the capillary, exchange of gas takes place, right? So, oxygen from the blood goes to the tissue, right? And carbon dioxide goes from the tissue to the blood. Is it clear? But that is the exchange in the capillary, right? Blood gives oxygen to the tissue and gets carbon dioxide from the tissue. So, blood loses oxygen and gets carbon dioxide, right? So, becomes what? Deoxygenated, right? So, that deoxygenated blood enters into the venous system and returns to the heart. So, that is the circulation. Okay. So, from this picture, the summary is arteries carry oxygenated blood and capillaries are responsible for exchange and veins carry deoxygenated blood and bring it back to the heart. Okay. Now, arteries are three types. Large arteries are also called elastic or conducting arteries. So, here, this is the aorta, which is a large artery. You remember I said? So, it is an elastic or conducting artery. In large arteries, you will see a lot of elastic fibers in the wall of large arteries. Lot of what? Elastic fibers. That's why large arteries can do like this. Look at me. This is the aorta. This is the heart. Okay. So when heart strongly pumps, right? A lot of blood enters into the aorta, right? Large artery. Wall is elastic. highly elastic. Okay, so aorta can expand. Make sense? So when heart pumps, a lot of blood rushes into the aorta. Aorta can expand, which helps, right? Otherwise, a lot of blood will stay in the heart, will not be able to get out if it doesn't expand. So large arteries are also called elastic arteries because in the wall you have elastic fibers. Medium-sized arteries are called muscular or distributing arteries. So these arteries, you see medium-sized arteries, these are called muscular or distributing arteries. They take the blood from large arteries and give to different organs. That's why they are called distributing, right? Taking blood from large artery and giving to the kidney, heart, liver, spleen, pancreas, right? Giving to different organs. That's why they are called what? Distributing arteries. They are also called muscular arteries because in the wall you have less elastic fibers but more muscle fibers. That's why they are called muscular. Okay? And small arteries are also called arterioles. So these are small arteries. You see, I showed you. These are also called arterioles. Okay? So arterioles give blood to the capillaries. Here you see the wall of three types of arteries. First, this is the elastic large artery. This is the muscular medium sized, and this is the arterial small artery. Here in the right side you see the amount of tissue. Just look at muscle tissue and elastic tissue. The blue bar is showing the elastic tissue, amount of elastic tissue. This is amount of muscle tissue, right? So in large artery, elastic artery, you see more elastic tissue than medium sized or smaller arteries. Makes sense? If you just compare these three, here you have more elastic fibers, right? In case of muscle tissue, medium sized muscular arteries have more muscle tissue compared to other two. Is it clear? That's why they are called muscular arteries. Then capillary. If you see the capillary wall is extremely thin, very thin. That allows the exchange of chemicals. Make sense? If the wall is thick, exchange will not occur easily, right? That's why capillary wall is what? Extremely thin. So the gas can easily, cross or pass through it. Other chemicals, nutrients, metabolic wastes, right, can pass through the capillary wall. So if you see the capillary wall, in most places the capillary wall is actually a thin layer of squamous cells. From NP1, you must remember squamous cells. Squamous cells are what? Tall or flat? Flat. So a thin layer of flat squamous cells. So this is one layer. This is another layer. So this is the capillary. So blood is here. So very thin wall. Okay, wall is very thin, formed by a single layer of squamous cells. Venule. Venule has squamous cells surrounded by pericytes. Another type of cells, these are called pericytes. So you see, these are the pericytes and these are the squamous cells, and that's the venule. And veins have muscle layer. You see this red layer is the muscular layer, and then connective tissue layer in the wall. venues are very porous. That means a lot of pores or holes are present in the venule, small veins, and that allows fluid and white blood cells to enter into the tissue. Yes.
I thought you just said that the squamous cell was in the capillary. Is that what you said?
Pericytes? No, which cells?
Squamous?
Squamous cells in the capillary wall. A single layer of squamous cells.
Okay, because I'm just looking at the book as you're lecturing, and this says endothelia. And I'm
Yeah, endothelium is this squamous cell layer is the endothelium.
Oh, okay, okay, that's the layer of squamous cell. Okay.
Yeah. Make sense?
Yes.
A single layer of squamous cell is the endothelium, but remember, endothelium is present everywhere.
Right.
In the large artery, innermost lining is endothelium, single layer of squamous cell. In medium-sized, single layer of squamous cell. So this is the artery. The squamous cell is the innermost lining. That is the endothelium. Okay, squamous cell. But in large arteries, you have muscle, thick muscle layer, smooth muscle, right? But in case of capillary, you don't have that. You only have the squamous. Make sense? Okay. This is the picture I did draw at the very beginning today. Now, the differences between an artery and a vein. Structural difference, if you see, artery, vein. Arterial wall is thick. The wall of a vein is thinner. Okay. So if you see the wall of an artery, it has thick muscle layer. Thick muscle layer. So this is thick. In case of vein, if you see the wall, this is the wall of the vein, which is thin. The lumen, this is the lumen, the opening inside. Since the wall is thick in artery, the lumen is narrow. Lumen is what? Small or narrow. Makes sense, because the wall is thick, this lumen is small. In case of vein, the wall is thin, right? And the lumen is what? Larger. Artery, since the wall is thick, always remains round. Make sense? Because the wall is thick, it will not get flat. Always what? Round. In case of vein, since the wall is thin, when the vein is empty, it will get what? Flat. When the pressure is low, it will get flat. Make sense? Since the wall of the vein is thin, just think about two tubes you have, okay? One tube, the wall is thick. So it will always, even if it is no water inside it, it will stay what? Round. Make sense? Because the wall is thick. If the tube has very thin wall, right, it will get what? Flat easily, right? So that's what I am saying. Since the arterial wall is thick, even no blood is there, it will remain open. Make sense? When the blood pressure is low or no blood inside the vein, it will get flat easily. Make sense? Okay. So inside the artery, the pressure is what? Okay, let's say the lumen is small, narrow, and round, larger and flat. Pressure is high inside the artery. High. Inside the vein, the pressure is what? Low. Because you remember I said, see here, from the heart, blood first enters into the arteries, right? Then passes through the capillaries, right? Then enters into the vein. So, arteries are closer to the heart, right? Veins are further away. So, when the blood passes through the capillary beds, the pressure goes really low, okay? And enters into the vein. So, inside the vein, the pressure is much lower than inside the arteries. Last one, inside the large veins, for example, the veins of your leg, you have valves. And the valves open only towards the heart, this way, upwards. So, the veins will open upwards. So, let the blood go towards the heart. Make sense? If the blood tries to go back down, the valves will stop that. Okay, so that will facilitate the flow of blood towards the heart. Make sense? Open towards the heart. So the valves are present in larger veins. A lot of valves in the veins of your leg. Tell me, from which veins the blood will easily go to the heart? The veins of your upper limbs or from your legs? From here, blood can easily go to the heart, right? Return. But from the leg is further down, right? And against the gravitation, right? Gravitational force. So, you need more valves here in the leg. Okay. Now, we'll see the arteries in the body. This is the arterial system. So first, we'll see the artery that takes the blood out from the heart. So this is the heart, left ventricle. Left ventricle pumps the blood, and blood enters into what? Aorta. Remember that? Aorta has 3 parts. So from the left ventricle, oxygenated blood enters into the aorta, and aorta has how many parts? 3. This part is called the ascending. Very good. Ascending aorta. Okay. Then you see this part is called what? Arch. Looks like St. Louis arch, right? So aortic arch. And this part is what? Descending, right? So ascending arch and descending aorta. Makes sense, right? Descending aorta is very long. It is the longest part. Okay? Anybody remember heart rests on a flat muscle that is called what? Diaphragm. Very good. So this is the diaphragm, right? And diaphragm goes like this. So this is the diaphragm. So descending aorta pierces through the diaphragm. Make sense? Okay. And above the diaphragm, this part of descending aorta is called thoracic aorta, and below abdominal aorta. So this part is the thoracic This part is called what? Abdominal aorta. Separated by the diaphragm. Make sense? Okay. These are two parts of the descending aorta. Now, from the ascending aorta, two very important arteries arise. Very important. And go to the wall of the heart. Which arteries go to the wall of the heart? Coronary arteries. How many you have? Right and left, right? Two. Coronary arteries. Remember that? So, coronary arteries, right and left, are the branches of the ascending aorta, and they enter into the wall of the heart, right? Gives oxygen and nutrition to the wall of the heart. From the aortic arch, how many arteries arise like this? Three. Okay. So, three important arteries. 1, 2, 3. Okay? This is called the brachiocephalic. Yes. Cephalic. Can you close the door, please? So, brachiocephalic trunk. Then left common carotid. Left common carotid and left subclavian. Okay, so three arteries. One is called trunk. Other two are called what? Arteries. What's the difference? Trunk is, if you see the artery is short, and the short artery divides. Okay, it's not long. So short artery that quickly divides, that is a trunk. Okay, so those three arise from the aortic arch. Now you tell me, brachiocephalic, the name has two parts, right? Brachio and cephalic. Brachio means what? Arm. You remember the brachial part in ANP1? So, brachio. Cephalic means head. Cephalic means head. So that means it is telling you this artery or trunk will give how many branches? Two. One will go towards the arm, another will go towards the head. That's why it is called brachiocephalic. So, this brachiocephalic trunk will divide into two. Okay? The one going towards the head, cephalic part, this is called the right common carotid. This is the right common carotid. And the one going towards the arm, this is called right subclavian artery. Sub means what? Under, right? Clavian means clavicle. So, one will go through under the clavicle towards the arm. Make sense? Under the clavicle. That's why it is called subclavian. Okay? Now you see one thing. Before this division, you had three here, right? Brachiocephalic trunk, left common carotid, left what? Subclavian. Where are the right common carotid and right subclavian? You need to think, right? Where are those two? Those two are the branches of brachiocephalic trunk. Make sense? So now you got what? Two common carotid right and left, two subclavian, two common carotid right and left, two subclavian right and left. Make sense? Now it makes sense, right? Because you have right common carotid, right subclavian, left common carotid, left subclavian. But left common carotid, left subclavian directly arise from the aorta. Aorta, right? The right common carotid, right subclavian, they are the branches of brachiocephalic trunk. So now you got two common carotid, two subclavian. Okay. So this is the left common carotid towards the brain, towards the head. This is the left subclavian towards the arm under the clavicle. So two subclavian, two common carotid. Now remember, when you will see a common artery, like common ilia, common carotid, okay, that means it usually divides into two. Common divides into two, okay? So this is right common carotid, it divides into two. This is left common carotid, it divides into two. So both common carotids, right and left, divide into two. External and internal. So common divides into what? External, internal, and external. Make sense? So this is internal carotid. This is external carotid. Internal carotid, external carotid. Make sense? Okay. So common carotid goes towards the head. Common carotid goes towards the head, right? And subclavian goes towards the arm, under the clavicle towards the arm. Is it clear? Now common carotid divides into two, right? External and internal. Both are going to the head. Now you tell me, which one will supply blood to the brain and which one will supply blood to the bones, skin, and scalp and other structures? Internal will go to the brain because brain is inside, right? The head. And external to the outer part of the head. Make sense? So that's why you have two, internal, external. So these two internal carotid arteries mostly supply to the inner part of the head, which is the brain. Okay? Internal carotids. External to the bones, skin, those structures, muscles of the head. Okay, so that's the head part. Now let's see. Subclavian, right and left subclavian. Will go towards the arm. Very good. So subclavian, when it goes under the arm, that means the armpit area, this area is called what? Axillary. Remember that? Axillary. So this is the subclavian. Subclavian, you already know that. When it goes to the armpit, it becomes what? Axillary artery. And when it enters into the arm, brachial artery. Make sense? This is the axillary area, this is the brachial area, right? So axillary then becomes brachial, okay, in the arm. You measure the blood pressure most of the time, right? From here, that means from which artery? Brachial artery, right? Take the pressure in the brachial artery. Now, when the brachial artery leaves the arm and enters into the forearm, it divides into two branches. How many? Two. How many bones you have here? Two. This is the radial thumb side, right? And this is the ulnar. So radial artery along the radius, ulnar artery along the arm. Make sense? So the lateral one is the radial artery, medial one is the ulnar artery. Is that clear? Okay. Then radial artery in the radial side, right? And here we do what? Take the pulse or train, right? From the radial artery. So then these two, radial and ulnar, go to the proximal part of the hand, and they form arches like this. They divide like this, divide like this, and form how many arches? Two arches. Okay? Two arches. Divide like this and form two arches. Is it clear? One is called the superficial palmar arch in the palm, another is called the deep palmar arch. Makes sense? Palmar arch in the palm. Okay? So superficial and deep palmar arches. Okay? See here? Deep and superficial palmar arch. And from those arches, digital arteries arise and go to the fingers, because from the palm, blood should go to the finger. So these are digital arteries. Okay. Okay. So that is the upper limb. Same thing in this side. From right subclavian, exactly same. Axillary, brachial, radial, ulnar, palmar. Okay, now everybody, this part is what? Thoracic aorta, right? And this part is the abdominal aorta. So let's talk about thoracic aorta. Okay. From the thoracic aorta, several branches arise. Several branches arise. And you see, this is the thorax, right? This is the thorax. So thoracic aorta is in this part, right? Abdominal aorta is in this part. So this is the thoracic aorta here. And from the thoracic aorta, a number of branches arise and enter into the muscles in between the ribs. Make sense? Like this. Enter into the muscles in between the ribs. Those are called intercostal arteries. Intercostal means in between the ribs. Make sense? Like this. So, intercostal. Okay. And go to the muscles in between the ribs. Make sense? Like this. Two other arteries arise from the lower part of the thoracic aorta and enter into what? This is what? Diaphragm. So enter into the diaphragm. Okay? Remember, the arteries or nerves go to the diaphragm. They are called phrenic. Phrenic indicates diaphragm. Okay? So these are called superior phrenic arteries because coming from above the diaphragm. Superior phrenic arteries. It makes sense? Coming from the thoracic aorta. It supplies blood to the diaphragm. Okay? Phrenic arteries. Now let's see the abdominal aorta. Inside the abdomen you have many organs, right? You have kidneys, you have adrenal glands, you have pancreas, spleen, stomach, small intestine, large intestine, right? All those are inside the abdomen. So there are several branches of abdominal aorta. First, from the upper part of the abdominal aorta, look at this. Two branches enter into the diaphragm again. So these are phrenic arteries too, phrenic diaphragm, right? But these are what? Superior or inferior? Inferior because going from below, right? So these are inferior phrenic arteries. So let's write here. These are superior phrenic and these are inferior phrenic arteries. Phrenic arteries. Superior phrenic arteries. Okay. Now, from the front of the aorta, this is the aorta from the front, not from the side, from the front, a trunk, that means a small artery, arises. That is called celiac trunk. Celiac trunk. Okay. Celiac trunk. Trunk is what? Long or short? Short. Right? Short, wide artery is a trunk. And it divides, I said, right? So it is short, then it divides into three. Like this. What are those three branches? Important, you need to know. One goes to the spleen, that is the splenic artery. Should be 1E in case of artery. So splenic artery goes to the spleen, this one. One goes to the stomach, that is the gastric. Gastric means stomach artery. And another one goes to the liver. What should be the name? Hepatic. Remember, liver, hepatic indicates liver. So this is the hepatic artery. Those are the three branches of celiac trunk. One goes to the what? Spleen. That is the splenic artery, right? One goes to the stomach. That is what? Gastric. Okay, not a stomach artery. Gastric artery, right? And another goes to the liver. That is called hepatic. Makes sense, right? Okay, so those are three important arteries. Then another one arises from the aorta, abdominal aorta, that is called superior mesenteric. Superior mesenteric, and another one below that, that is the inferior mesenteric artery. Remember, easy to remember, superior mesenteric supplies blood to the small intestine mostly, and inferior mesenteric should supply to the which intestine? Large. Smaller is above, right? Large is below. So superior mesenteric supplies to the intestine. Superior should be which part? Small intestine, right? And inferior mesenteric supplies blood to the large intestine. Make sense? Okay. So this is for small intestine, and this is for large intestine. So a number of organ is already covered, right? You got liver supplied by hepatic artery, right? Spleen supplied by splenic artery, and another one you got gastric, right? Supplies the stomach. And you also got superior mesenteric and inferior mesenteric for small intestine and large intestine. Make sense? But you have other organs too.